In this video lecture, we're going to be covering Windows Deployment Services, or WDS. Specifically, we're going to be talking about what WDS is. We'll be discussing the pre-boot execution environment, managing network boot programs, directing a client to the appropriate network boot program, configuring a router to forward broadcast, using DHCP options 60, 66, and 67, network boot referral, the benefits of Windows Deployment Services, deployment server and transport server, prerequisites for installing WDS, WDS considerations, boot image and install image, we'll cover what those are, WDS infrastructure for custom Windows deployments, expected deployment result wizard, TFTP or Trivial File Transfer Protocol, boot image and installation image priorities, standalone server mode, tools for managing WDS, WDS Management Console, WDS Client.exe, Scenario 1, which is going to cover the small business environment, Scenario 2, which is going to cover the medium-sized business environment, and Scenario 3, which is going to cover the large enterprise environment. So let's talk about what WDS is. So again, Windows Deployment Services, or WDS, or WDS stands for Windows Deployment Services. Windows Deployment Services is a server role that you enable that allows you to remotely deploy Windows operating systems. So rather than have to put a CD into a computer and install Windows 10 or Windows 7 or Windows 8, you can actually boot off the network or boot the client machine off the network, and you can install Windows straight from the network. The server role, the WDS server role, does come with Windows 2012 R2 by default. You can use it to set up new computers by using a network-based installation, so kind of what I was just talking about. And the major advantage here is that there's no need to install each operating system directly from a CD or USB drive. You just do it off the network. So Windows Deployment Services makes use of a pre-boot execution environment. This is also called PXE booting or PXE boot. Pre-boot execution environment is an industry standard client-server interface that allows network computers that are not yet loaded with an operating system to be configured and booted remotely by an administrator. So in a nutshell, what you're doing here, or what PXE is allowing you to do, is it's allowing you to boot to a Windows installation without the need for physical installation media. So to expand on that last slide, DHCP allows the client to receive an IP address to gain access to the network servers. So when you turn it on, in your PXE booting, the computer requests an IP address from the DHCP server, and then it gives it an IP address with some additional information in it, which we'll talk about in a future slide. The BIOS of the client computer or a downloaded program called the Network Bootstrap program, often run via a flash drive or a CD, uses a set of uses an API or application programmer interface to automate the booting of the operating system and other configuration steps. So this is a standard method of initializing the PXE code and the PXE ROM chip or boot disk. The PXE process basically consists of the client notifying the server, so this would be the Windows Deployment Services server, that it uses PXE. If the server uses PXE, it sends the client a list of boot servers that contain the operating systems available. So the Windows Deployment Services or the DHCP server basically has to be configured to notify clients that are PXE booting which servers are PXE enabled. So basically, going through the setup of Windows Deployment Services, you also have to configure the DHCP server options, which we'll talk about here in a little bit. So next, the client finds the boot server it needs, and then it receives the name of the file to download from the boot server. And then after that, the client will download the file using TFTP, or Trivial File Transfer Protocol, and then it executes it, which will start to load the operating system. So there are several advantages of using PXE. One of the first advantages is that the client machine does not necessarily need an operating system or even a hard disk to PXE boot. And this ties into the next point here. The client machine can be rebooted in the event of a hardware or software failure, and it allows the administrator to diagnose and perhaps fix the problem. So in other words, you can actually use the PXE functionality to boot to another set of networked troubleshooting tools. I used one in the past that was tied into a open source imaging software that would actually allow you to run a memory check on the system right from the PXE boot environment. So you didn't need any hardware or additional software to run this, just booted right off of the server and allowed you to troubleshoot the system. And then the other great thing about PXE is that it is vendor independent, which means that almost any computer can PXE boot, and that basically allows you to easily add new computers to the network. It's one less thing you have to worry about when you're purchasing new hardware. So let's talk about managing network boot programs. So a network boot program, NBP, is the first file that gets downloaded from a WDS server in this context, and it's executed as part of the network boot process. So it basically controls the beginning of the boot experience. So when you go through your lab for this module, you'll notice that you have to press F12 to initiate a network boot. That's part of the network boot program. So this option could do a bunch of different things. For example, you could use a network boot program that does not require the user to press F12, and it just immediately begins the network boot. Again, it's basically just the first little bit of the PXE booting and WDS process here. Network boot programs are specific to architecture and firmware of the client. So if you have on your WDS server, if you're booting 64 and 32-bit clients, you have to have both a 62-bit and a 64 and a 32-bit network boot program. There is Itanium-based processors out there. If you are booting Itanium-based computers, or PXE booting Itanium-based computers and trying to install operating systems on them remotely with WDS, you also have to have an Itanium-based network boot program. So there are two methods that you can use to direct a client computer to the correct NBP. So the first option, and this is the one that Microsoft recommends, is you can configure your router to directly forward the TCP/IP broadcasts. And basically what will happen is the client will contact the server directly for the network boot program in question. The other option you can use for this is to use DHCP options 60, 66, and 67. And then what will happen is when the client requests a IP address from the DHCP server, the DHCP server will relay these options to the client, and then the client will be able to boot from the correct network boot program. So if you have a larger network, so this would be a network that has maybe multiple subnets and routers, you can update your routing tables in your routers for networking equipment to make sure that DHCP traffic is directed correctly. This basically means that if you need to use WDS on more than one network, you're able to. So you would use your router to forward these specific types of DHCP requests. But if you are booting the client, but if the booting client, the DHCP server, and the Windows Deployment Services server are all located on the same network, then you don't need to have any configuration done with your router. Basically, what will happen is the client the client's DHCP broadcasts will reach both the DHCP server and the Windows deployment server. And since they're all on the same network, they're basically able to talk to each other. If either the DHCP server or the Windows deployment server are on a different network segment from the client, then Microsoft recommends that you change the routing table in your router. After the client computer has obtained its IP address, it contacts the Windows deployment server services server directly. And again, this is using DHCP packets to obtain the name and the path of the network boot program to be downloaded. So again, just to reiterate, if you have a larger network and you need to be able to boot off of, or to PXE boot to your WDS server, and your WDS server is located on a different network than your client machine, then you'll have to change the routing tables on your router to forward these types of DHCP requests. If not, if they're all on the same network, or if you have maybe one network where you bring computers for reimaging, then the DHCP server and the WDS server and the client all should be able to talk to each other without any sort of routing configuration. So if you want to configure your router to forward broadcast as recommended by Microsoft, here are the following, specific changes are what you need to make in order to do this. So first off, all DHCP broadcasts by client computers on UDP port 67 should be forwarded directly to both the DHCP server and the Windows deployment server. And again, this is done on your router. And then if the router is one of the combination routers that has a built-in firewall, you need to allow traffic through UDP port 411, and then you also need to allow traffic, any UDP ports used for TFTP and multicasting is specified on the Network Settings tab of the server properties in the Windows Deployment Services MMC. So when you log into the WDS MMC, you'll be able to see this port information. So if you're going the route where you need to forward traffic via your router, these are the networking changes that you'll need to make. So again, this isn't the recommended method for doing this, but it does work. So if you are using the DHCP options as opposed to reconfiguring your router, basically what you're going to do is you're going to configure all three of these options. So option 60, option 66, and option 67. So 66 is the client identifier, and you use this to set the PXE client string. And just a quick note here, this only applies if you have DHCP server on the same server as Windows as the WDS server. If you don't, then you don't need to set this option. Option 66, this is the boot server host name. So if you, again, if you don't want to reconfigure your router to forward DHCP traffic, you just put in the host name of the boot server. So this will be the WDS server. And then option 67 is the boot file name. So boot file name, again, being that network boot or the MBP file. And option 67, this file will basically allow you to set various settings about how the network boot works. So if you have to press F12 to boot, or if you don't, there's a few other options you can enable for this. But again, these are the three options that you have to enable if you are going to use the DHCP options to configure your clients to boot to a WDS server. So just a really brief note about some of these options here. Options 66 and option 67 are considered a network boot referral. So basically a network boot referral is when a client is directed to download an NBP from a different server other than the one it was in communication with through DHCP. So in other words, if your WDS server and your DHCP server are two separate machines, or if that service is running on two different machines, you would be using options 66 and 67 and a network boot referral to configure this. So just a few scenarios here where you might want to consider using a network boot referral. So if you want to direct a client to download an NBP that is located on a different computer or network location, you might use a network boot referral for this. If you wanted to limit traffic to a specific server, maybe you needed to take one WDS server down for another one, you could change the network boot referral location to a server that can handle the load. If you want to set up a complex network and Active Directory domain services topologies, sometimes networking and ADDS topology does not line up. This could be because of incoming network boot requests or answered over a WAN, but you want a local server to provide the boot image. So using a local server generally is quicker, and you might have one at a specific site that you have set up for imaging that specific site so that a client's image quicker. So you might use a network boot referral to boot to that site versus one across WAN. Also, to enable you to keep another scenario here, enabling you to keep only one copy of an image and therefore reduce the overhead of keeping multiple images in sync. You might use a network boot referral for this as well. So to configure network boot referrals, there are two steps that are involved. So the first is you have to configure the front end and the back end server. So the front end server is a server that will answer the client's network boot request. So this would be like a DHCP server. You'd give it an IP address, and then it would direct it to the client, or it would direct the client to the correct server. The back end server is the server that the client will directly download the NBP from. So in this case, it's usually your WDS server. So second, you'll need to pre-stage clients and then direct them to the backend server. And this is only required if you are not using options DHCP and 66 and 67 to redirect the clients. So we'll talk about pre-staging here in a little bit. So let's take a look at a few network boot referral examples. So in this case, this example is covering a first order referral from a Windows deployment server. So this would basically be if you want to refer, have one WDS server refer to or client requests to a second WDS server. So in this case, let's just go over what's happening. So computer A comes online, and the first thing it does is it requests an IP address from the DHCP server. So in this case, the DHCP broadcast packet is sent out over the network, and then the DHCP server responds. So that's going from here, and then the DHCP server responds with an IP address. In addition to this, WDS1 is configured to also return its information. So along with the IP address, it's also going to send information to computer A. Computer A is then going to start the PXE boot process, and it's going to request the NBP file from WDS, in this case WDS server 1. And then WDS server 1 is going to respond to computer A and say basically, hey, I don't have your file, but let me refer you to WDS server 2. So basically it's giving the information for the second WDS server. Then computer A is going to say, okay, give me the file. And then WDS server 2 is going to return that file, and it's going to allow the computer A to continue with the PXE booting process, or the first option when he PXE boots. So this would be again the option to press F12 to boot the computer from the WDS server. So just in a nutshell, just to recap here, this would be if you want a WDS server to refer to a second WDS server for the network boot file. So this example is a little bit more simple than the first one we looked at. So this would be a first order referral using DHCP options. So remember with this example, or with this methodology here, on the DHCP server, we are configuring options 66 and 67. to return some information along with the IP address information. So let's go over this example. So in this case, computer A comes on the network and it PXE boots and it requests a DHCP information from the DHCP server. In this case, since we configure the options 66 and 67, it's going to return that information to computer A, and in addition, it's going to return options 66 and 67. So since option 66 is directing the computer A to the WDS server, and option 67 is directing the file path, basically, so where to download the network boot file, the network boot program file, excuse me. All it needs to do is this one little function here. So there's not a bunch of extra steps like we saw in the previous one. So now computer A basically is just set up to request the file, so it knows where server the WDS server is, and it knows where on the WDS server that file is located. So it says, hey, give me this specific file, and then from there the WDS server returns that file and allows the computer to use the network boot program in order to boot from the WDS server. So in this example here, we are basically combining the previous two examples. This would be an example of a second order referral using both the DHCP options and the Windows Deployment Services options. So first off, the computer A is going to PXE boot to the network. It's going to send a DHCP broadcast packet to the DHCP server. Then the DHCP server is going to return an IP address along with options 66 and 67. So in other words, the advantage here is that the WDS server isn't listening for these requests, isn't listening for the DHCP broadcast request. The DHCP server just sends that information back to computer A. So now computer A knows where the WDS server is and what file it needs to download. So it requests that information from the WDS server. But the WDS server in this case is saying, hey, no, I don't want you to download the one on my, or download the one from my server. So I'm going to refer you to WDS2 to download the correct file. So then computer A then requests that network boot program file from WDS server 2, and then WDS server 2 returns that file to computer A. So again, this is pretty much, it's very much like the first example we saw, and it combines elements of the second example we saw. But the advantage here is that the first WDS server doesn't necessarily have to be listening for DHCP broadcast requests, which can clear up some of its networking traffic. So having used Windows Deployment Services before, I can tell you that even in a small environment, there are many, many benefits to using Windows Deployment Services. It's one of those things as an admin, I always advocate trying to be as efficient and effective as possible, and Windows Deployment Services is definitely one of those tools that allows you to do that. So first off, it allows network-based installations of Windows operating systems. So this reduces the cost and complexity of installing Windows and getting an operating system configured as opposed to manual installations. Once you have WDS configured, you can actually install an operating system in about 5 minutes. And this includes, in addition to the operating system itself, you can also set up deployment packages that contain any software your organization might use, along with any custom configurations your operating system has. So gone are the days of you having to put the CD in, install Windows, then update Windows, then install all the applications and configure it. It's all just done for you in about 5 minutes versus you spending 2 or 3 hours potentially doing this. So it's definitely cost savings. Moreover, it's more efficient it's less error prone too, because you have one image you're pulling from versus relying on a technician to repeatedly follow steps to get everything configured the way that it ought to be. Second bullet point here, it supports deploying images for mixed environments, including Windows 7, Windows 2000, and Windows Server 2008 R2 through Windows 8.1, I guess now 10, and Windows Server 2012 R2. So you can actually deploy images from a bunch of different flavor, or you can actually deploy a bunch of flavors of the Windows operating system from 7 and up. It uses the standard Windows setup technologies, including the Windows pre-installation environment, Windows PE, .wim files, and image-based setup. So if you've custom configured Windows before, this is a very streamlined and straightforward way to do it, and it's very much within the Microsoft family. It also transmits data and images by using multicast functionality, which means if you have, let's say you have 30 computers you're imaging, rather than all 30 computers downloading the file separately, the multicast functionality allows the WDS server to effectively broadcast the download of the information one time versus having to do it 30 times. So what that means is less network congestion, and your clients get imaged all that much faster. So rather than having to do them sequentially, it's basically doing them all at one time. So it's 5 minutes for 30 computers versus whatever 30 times 5 is. 150 minutes. Next bullet point here allows you to create images of a reference computer using an image capture wizard, which is an alternative to the previously used ImageX tool. So what that means is you can create what's called a gold image. So if you have to, let's say you have one model of IBM computer that you use, and you need to set it up a specific way for a specific department, say accounting. Well, you might have all the accounting applications installed, along with all the drivers for that particular laptop, and all the Windows updates applied. And then you might have that same laptop, but you might have a customer service staff that needs another set of applications installed. So you can custom configure, or so you can install or create another gold image for the customer service department versus the accounting department. And again, that allows you can still quickly deploy that to people, so you don't have to kind of guess what each department requires in their image. Third bullet point here, this allows you to add driver packages to the server and configure them to be deployed to the client computers along with the install image. So this is actually pretty big. If a driver gets updated or changed, it used to be you would have to grab a copy of the computer that you had the gold image set up on initially. You'd have to deploy a fresh image, update the drivers, and then recapture the gold image. That's no longer the case because Windows Deployment Services allows you to add a driver package that gets configured at install time, so that all your drivers are ready to go when you're installing Windows. So you don't have to do any sort of updates, or you don't have to manage the driver packages for your install Windows, or for your remote installs. You can just apply a updated version of the driver at install time, and your new freshly imaged machine will have the latest driver for that particular piece of hardware. So that one's definitely really big because it cuts down on the amount of maintenance you have to do to keep your images up to date. So during the installation of Windows Deployment Services, you have the option to install the deployment server, the transport server, or both. Now, just up front here, typically you're going to be installing both the deployment server and the transport server on a WDS server, but there are definitely some reasons why you'd want to split the workload up, and typically that's for high deployment or high workload images or servers, excuse me. So the transport server, this provides a subset of WDS functionality. It contains only the core networking parts needed for WDS to function. It can be used if you want to have a PXE server that allows clients to PXE boot and download your own custom setup application. Use it if you do not want to incorporate all of WDS. Again, there are reasons why you'd want to split it up, but typically you'll have these both configured when you set up a WDS server. So the deployment server, this is the full functionality of Windows Deployment Services. And note that the note that the deployment server is dependent upon core parts of the transport server. So in order for you to have the deployment server, you have to have parts of the transport server as well. So like any piece of software, there are definitely some prerequisites that you should consider before installing WDS. So the first one is Active Directory Domain Services. A Windows deployment server must be a member of an Active Directory Domain Services domain or a domain controller for an ADDS domain. The ADDS domain and forest functional levels are irrelevant. All domain and forest configurations support WDS. One thing to note is that ADDS is not required if the server is configured in standalone mode. So standalone mode meaning it's just its own server. It doesn't have any tie-in to Active Directory. But there are definitely some advantages if you have an Active Directory network to set it up in Active Directory mode versus standalone mode, mainly it being that it ties into Active Directory. As we saw in a few slides ago, one of the prerequisites is that you have DHCP and DNS set up so that your computer, your clients connecting up to the WDS server can PXE boot. You need an NTFS volume. So the server running WDS requires an NTFS file system volume for the image store. One thing to note is that Microsoft does recommend that your NTFS volume is a separate volume from your server OS. So if you can partition it, or if you can add an additional set of drives to act as your image store, that's the recommended way to do it. Credentials, so to install the role, you must be a member of the local administrators group on the server. To initialize the server, you must be a member of the domain admins group. So you have to be an administrator both locally and at the domain level. So a few considerations for Windows Deployment Services. First off, it's not common to split a WDS's server's functionality among different computers. So we talked about splitting up those two roles that you must have installed for WDS. You shouldn't typically segregate them. It is supported for you to do that, but you don't typically do it. And next bullet point here, and this is probably pretty important if you have if you're a Windows Server core shop, you cannot use WDS in the server core installation. It has to have a GUI. So one important piece to WDS and just imaging in general is the concept of a boot image and an installation image. So a boot image is the image that the operating system uses to boot into the environment that you, to the install environment. So just to read here, the boot image is the image, the boot image is the bootable environment that you initially boot the computer into. So this is sort of like this pre-boot environment. The install image, these are the actual images that you deploy. So if you set up a gold image and you install your software, your drivers, you make your custom configurations, the install image is what actually contains that information. So just to distinguish again between the two, boot image is what's used to boot the operating system for deployment. The install image is the actual installation files and configuration. So let's discuss some of the custom deployments or some of the custom things that you can do for deploying your operating system. WDS offers the ability to control all aspects of the deployment process, including a variety of different configuration options. So first off, you can control the boot parameters of the PXE clients, including the boot program, which we talked about earlier, the prompt policy, and the boot.wim instance. You can also have the ability to control the WIM and VHD images that are deployed to the client. So again, you might have one for accounting, one for customer service. You might have an image set up for 64-bit clients. You might have an image set up for 32-bit clients. There's all sorts of things that you can do. You also have control over the drivers that are deployed to the client. This in Server 2012 R2 more so than previous versions of Windows deployment services. You can control the drivers that are deployed, and those are deployed at install time. You also have control over the unattended files that are used to customize the setup experience for the client. So you can actually configure it using an unattended or using an answer file to completely do a 100% hands-off configuration of an operating system, so that when you boot up the machine, it basically boots into either into Windows or it boots into a screen that has or boots into the login screen, excuse me. So if you want to get really fancy with setting up Windows and you want to set it up so that you have a one-touch, basically effectively a one or two button install, you can do that through the use of answer files. You don't always have to, but the option is there. So I just really briefly want to talk about the expected deployments results wizard. So this is a function that enables administrators to model the process of deploying a computer and see what boot images, install images, and driver groups the computer will be offered from the server. So this is basically just giving you or performing what's called a what-if analysis. It's designed to help administrators efficiently test the configuration changes to their servers and see how they impact deployments to all or specific pre-stage client computers. This is actually really valuable when you're testing or when you're doing some testing of some advanced configuration options by WDS. Now, this is just giving you an analysis, and it's using algorithms to kind of figure out what would happen if you made a specific change. But it's always best to make this change in a non-production environment and then do some testing on an actual physical computer before you push this change out to be part of your imaging process. So it's a good tool, but it's not to be replaced by doing physical actual testing. So let's talk just a little bit more about TFTP. So again, TFTP stands for Trivial File Transfer Protocol, and it's basically enhanced and delivers improved results and performance in Windows Server 2012 R2. Basically what WDS uses TFTP for is to download the files that are needed to boot the pre-boot execution environment, so the PXE files. So that network boot program that we had discussed earlier, it's transferred to the PXE booting client via TFTP. So let's talk a little bit more about the boot and install images. So when you have multiple boot or install images available for client computers, clients will be presented with a boot and an install menu that displays the section of images to choose from. So it's basically just a drop-down list or a select list that allows you to select the specific image that you want. So When you're creating these images, it's important to give the image a proper name or a descriptive name so you know exactly what you're downloading or what you're installing when you select that particular image. WDS now allows you to set priorities to control the order that both boot and install image listings are presented to the clients. So if you have one that you install more often, you can set it at a higher priority list or a priority level so it shows up higher in the list. And that's integrated directly into the WDS interface. So this is a change. So being able to set priority was a change that was added to WDS or the WDS role in Server 2012 R2. So we mentioned standalone server mode. So standalone server mode, it removes the dependency on Active Directory. Again, when we're talking about servers and we have member servers and standalone servers. Standalone servers are any servers that function outside Active Directory. So standalone servers remove the dependency on Active Directory. You still require a DHCP, DNS, and sufficient permissions to install and configure WDS on this standalone server. And a local store is used to retain information about pre-staged devices versus one on a network share. Again, with the standalone server, you do lose some functionality of WDS. One of the great things you can do with a WDS server is you can automatically add a computer you are imaging to the domain. So that's, again, one less step you have to do when you're deploying a computer, or excuse me, deploying an image to a computer. You can actually set custom naming schemes too with Active Directory integrated WDS servers. So you can automatically generate unique names for your clients. So there are some pros and cons to this. If you have maybe you have an environment that doesn't have Active Directory, or you don't necessarily want your WDS server to be part of the domain, then you may set up a standalone server. So we do have several different utilities for managing WDS. The first and probably the most often used one is the Windows Deployment Services MMC Snap-in. You can remote into the server you're using to connect up and use the WDS server or to interact with the WDS server. The next one is the WDS util command line tool. This is just a command line tool that you can use to issue different commands to your Windows Deployment Services server. And then finally, as with most Windows operating systems now, there are PowerShell commandlets for WDS that you can use to further interact with your WDS server. The PowerShell commandlets are extremely scriptable, so if you need to do some automated deployments, or if you need to do some sort of automated management of your WDS server, PowerShell is probably the best way to do that. So the WDS Management Console, or the MMC, it provides users with more convenient features to configure deployment options for their clients. There are a ton of different configuration options you have for sure. So some of the features include creating client unattended dialogues to make it easy for administrators to author client unattended files. Again, the unattended files are basically answer files. So when you go through and you install Windows by default, you often have to answer several questions in order to before you are able to actually access and use the computer. So answer files basically answer those questions automatically for you. You can approve, it has something called the Approve Pending Device Wizard, which simplifies and extends the functionality of the previous approve options. So basically what this wizard allows you to do is it allows you to prevent unauthorized clients from PXE booting to your WDS server and pulling images from it. So this would prevent someone from coming off the street, coming into your environment, connecting up to your network, and then just getting your company's install image installed onto their computer, which can be a security risk. So setting up the setting up your WDS server to authorize devices before it deploys the image is usually a good security measure to take, and the WDS management console allows you to do that. It has built-in support for pre-staged devices that supersede the remote installs tab of Active Directory users and computers of the Active Directory users and computer snap-in. So this allows you to basically pre-stage some devices in WDS versus having to do it in Active Directory users and computers. So just really briefly here, WDSclient.exe allows you to manage the full functionality of the WDS server. WDS util also enables you to script common tasks. Again, there are also PowerShell commandlets that you can use to interact with your WDS server via the command line. Both allow you to do to script common tasks, and they can make automation very easy for you. So definitely go and play with the WDS client command. Look at WDS util as well, and also look at the PowerShell commandlets for WDS. So let's take a look at some scenarios for how WDS can impact certain environments. So here's scenario one. This is the small business. So Fabricam Inc. is a small business with a single office. We have Monica Brink. She's Fabricam's resident IT guru, and she is responsible for maintaining the IT infrastructure for the company, which consists of 25 client computers running, unfortunately, Windows XP SP2 Professional, and a single server running Server 2003 SP2. So this is, as of right now, this is quite an old network. It's not supported by Microsoft anymore. The server functions as a file and print server, a web server, Exchange server, DNS, DHCP, domain controller, so it pretty much does everything. The computers are linked by 100 megabit per second connection, so not too bad, but not too quick either. Monica's given the task of moving all of the client computers to Windows 7, Windows 8.1, or Windows 10 operating system, and upgrading the single Windows Server 2000 to Windows Server 2008 R2, Windows Server 2012, or Windows Server 2012 R2. Note here, it's important that she makes the switch work as quickly as possible so that, we should note here that in this task, it's important that she makes the switch as quickly as possible so that office workers can continue their work. So she doesn't want to create any downtime for her office workers. In the past, she's deployed new operating systems for a computer one at a time. Almost 19 hours to set up the operating system all on on all of the client computers. So, just to recap here, she's got an older environment, doing things manually, and she's given this task on upgrading computers, and just to install the operating systems on all of her PCs the first time took her almost 19 hours to do. So this might be a weekend project. If she was to do it manually, or she'd have to do them one at a time. It could take a really long time to do them all without impacting the end users. So moreover here, Monica is the only IT professional at Fabricam, which means that she also must help teach the users about the new operating system. That's a really important piece for probably another topic here, but end user knowledge and teaching the end users, so end user training, is really important, especially when upgrading to a new operating system. Monica chooses to use WDS services here. She makes the smart choice because WDS allows her to save time by running several installations simultaneously. So she could install the operating system on all 25 of her computers at the same time if she wanted to. That would take advantage of that multicast functionality we were talking about, which would even save her even more time. She can use custom install images with pre-installed applications. This is really useful, especially if in this environment all of the users needed the same set of applications. She could use her custom install image to pre-install all of the applications at once. She can also create an image by using the Windows Deployment Services image capture wizard. This allows you to quickly capture images from reference computers. Even if she had more than one type of computer or more than one department needing different applications installed, the image capture wizard makes it really easy for her to do that. So let's look at the next size up. So this would be a medium-sized business. This is scenario 2. So we've got Northwind Traders. It's a shipping firm with 3 different offices. So they have a central office in Tooth City and branch offices in the towns of Brushville and Floston. Ron Gable is one of 6 IT staff members at Northwind Traders. His responsibility is maintaining the 250 client computers used by the company's employees. These are mostly desktop computers, but the sales force uses laptops for customer presentations. There are 200 computers in the central office and 25 computers in Brushville and Floston. So in this instance, Ron has 3 Windows Deployment Services servers at the Tooth City office, one in each of the branch offices, and one in each of the branch offices which are administered remotely. Ron's supervisor has tasked him with deploying Windows services, with deploying Windows 7, Windows 8.1, or Windows 10 to the whole company. So previously, this would have involved many expensive trips to Brushville and Floston. It would have taken Ron several weeks to complete. He wants to use Windows Deployment Services to deploy Windows remotely. However, company policy dictates that there can only be one DHCP server on the corporate network, and this server is located in the Tooth City office. So in this case, Ron also chooses to use Windows Deployment Services because he can use the unattended setup to deploy Windows to computers at the branch sites without physically being present there. He doesn't have to travel there. He can configure the computers to automatically grab the system image and start installing. He uses his existing replication solutions to deliver the images to the branch site servers. So he has his server in his main office is set up to replicate the images to the branch site servers. Then he uses the network boot referral system to minimize the network traffic between the branch site and the central office. Oftentimes those WAN links are slow. So basically in this case, what's happening is since he has one DHCP server at his main office, his clients are asking that DHCP server where the WDS server is. The WDS server responds with the one in the main office. Then he has it set up so that when a client requests that the network boot file, it gets referred instead to the branch office, depending upon where the client is physically located. And then from there, the computer will download the image, the boot image and the install image from the WDS server that is at each branch site, rather than getting it from the main office, thus making it a little bit faster, or quite a bit faster. So here's the third and final scenario. This will be a large enterprise. So Shu Ito is the network architect for Wide World Importers, which is a large enterprise with 5,000 employees and offices all over the world. The major employee centers are located in the United States and Germany, and there are 13 branch offices in other countries. Shu has 5 servers available to him in the US hub, 2 in the German hub, and 1 in each of the branch offices. All of these servers are hired on 2-year leases. Worldwide Importers is replicating the accounting department's 200 computers replacing the accounting department's 200 computers with computers running Windows 7 or Windows 8.1. She would like to deploy a Windows Server 2008 R2, Windows Server 2012, or Windows Server 2012 R2 image to any of the newly leased servers in the US office. The servers in the German office and the branch sites are the responsibility of the local administrators. Currently, deployments at Worldwide Importers are done using RIS, and Shu wants to ensure that existing computer building processes are preserved with the move to Windows Deployment Services. In addition, it is important that each computer is deployed with an operating system in a language that is appropriate for the country or region. So Windows Deployment Services gives Shu the option, it gives several options that allow him to address some of the challenges he faces. So the first one here is that appropriate language packs are used to reduce the number of required images. So this would be part of that answer file we had talked about earlier. One of the questions that Windows asks you by default is, hey, which language do you want to use? And the answer file will automatically select the correct language based upon some programmatic logic here. He can manage all of his Windows Deployment Services servers from a single computer using the replication technology. He can use multicast deployments to preserve bandwidth while deploying images to many computers concurrently. So again, here's where multicast comes into play. If you have many computers that you need to deploy an image to, multicast definitely reduces the amount of traffic and also deploys the images quicker. And finally, and this is probably one of the more important things, he can write scripts to automate common management tasks. So if he has to deploy a specific language pack, or if he has to deploy a specific set of drivers based upon the region, the script that he writes using the WDS util command or the PowerShell commands will help him automate the tasks and make his task much quicker and much more consistent. So we talked about, just to recap what we talked about here, we talked about Windows Deployment Services. We discussed what WDS is. We discussed the PXE booting or the pre-boot execution environment. We talked about managing the network boot programs. We talked about directing a client to the appropriate network boot program, whether it be located on one server or another. We talked about configuring your router to forward broadcasts, which, just to recap, is recommended by Microsoft. But if you can't do that, then you also have the options to set up the DHCP options 60, 66, and 67 to let your IP-based or your clients connecting up to your network know where your WDS server is and where those network boot programs are. We talked about network boot referral and how you can use that to refer one WDS server to another. We talked about the benefits of Windows Deployment Services. There are definitely many. We talked about the deployment server and transport server the deployment server and transport server services functions. We talked about the prerequisites for installing Windows Deployment Services, some WDS considerations. We also talked about the boot image and the install image and what the difference between those are. We discussed the WDS infrastructure for custom deployments. We discussed the expected deployments results wizard, but again, that's no substitution for testing your deployment. We talked about TFTP and how that's used in WDS. We also discussed boot images and install image priorities. We discussed the standalone server mode and why you would use that versus the Active Directory integrated mode. We also discussed tools for managing WDS. We briefly talked about the WDS management console and the WDS client.exe. And we also went through 3 different scenarios, the small business, the medium business, and the large enterprise, and talked about how WDS can be used in either of those. So that concludes the presentation on Windows Deployment Services.